Alright, so if we're going to try to find maxes and mins and inflection points, we're given the derivative. I like to draw a sketch of the derivative just to get a visual and for sure find our maxes and mins. So this is, the 6 indicates that it's a positive leading coefficient. It's a cubic, it's the first degree and then 2 more degrees, so a positive cubic, which generally the shape looks like that. It's got an x-intercept at -1 and an x-intercept at 2. And it's a double root at 2, so it's going to bounce off the x-axis at 2. So this is the shape of our derivative. So that's y prime. Alright, so what happens at -1? Well, our derivative is negative, and then our derivative becomes positive. And right here, our derivative is 0. So if it's a negative derivative, that means it's decreasing. The original is decreasing, and then it's increasing. So if something decreases and then increases, we have a minimum. So there's a minimum at x equals -1. And at 2, the derivative is positive, and afterwards it's positive. So it's, the original is increasing, then it's 0, and then it's increasing again. So if it increases, then it's 0, and then it increases again, that indicates that there's an inflection point right there. So it looks like there's an inflection point at x equals 2. And we should probably confirm that by finding, because it looks like there's going to be another one where the second derivative is 0 right here. So we're going to have to find a second derivative. We could use a product rule if we wanted to. I'm going to distribute the 6. So then our second derivative is this, derivative of that, which is 2 times x minus 2, plus x minus 2 squared times the derivative of that, which is 6. So now we set that equal to 0 and solve. I'm going to pull out an x minus 2, and I'd be left with 12x plus 12 plus 6 times another x minus 2. So that's 18x plus 12 minus 12. Nice. Set those equal to 0, we get x equals 2 and x equals 0. So we do have an inflection point at 2. We have another one at 0. And there is no point. The only way we could have a maximum is if our first derivative is 0, and there's only 2 times that occurs. So this is all we know, and there is no maximum.